Alright, today we begin the course of factoring, and we start with the idea of factoring by grouping. And this is going to be the way we're going to go about ultimately factoring trinomials, but this is the first step, so really the next lesson we'll get to the more complicated factoring. But factoring by grouping it always involves four separate terms, and the idea is that basically this. Let's say, for example, we had a times x plus 2, and we also had b times x plus 2. Realistically, don't we have in that given situation a and b are both times x plus 2? Or you can think about it with subtraction. If you had x times m plus n minus y times m plus n, well, both x and y are being multiplied by m plus n, so you could make the case of, well, really you have x and negative y both being multiplied by m plus n. So the way it looks when you actually start doing the factorization would be, say, you had x cubed minus 2x squared plus 4x minus 8. In these situations, what you're going to focus on is, first focus on just the first two terms. We talked about prime factorization. What is the prime factors, common to GCF, of x cubed and negative 2x squared? I believe it's x squared. So we can factor out an x squared, leaving x minus 2. So if you followed that, I looked for the GCF of these first two terms, factored it out, and then asked myself what would be left if I took an x squared out. Well, there would be an x in this term and a negative 2 left in this term. Now let's focus on the last two terms. Okay, we have a plus sign there. And what is the GCF between 4x and 8? Well, they both don't have an x, but 4 is the GCF between 4 and 8. So if I factor out a 4, I then have x minus 2. And the key to this is x minus 2, x minus 2. So kind of like the previous examples, I have x squared times x minus 2, and I have 4 times x minus 2, so I have x squared plus 4 times x minus 2. That is how you factor by grouping. And I've got a number of examples to go over. So x cubed minus 2x squared minus 9x plus 18. Okay, well, look at the first two terms. I think you can clearly see that just like last time, it's an x squared, leaving an x minus 2. Now, if I factor out, it looks like the GCF here is a 9, but if I factor out a 9, I'm going to be left with negative x plus 2. And the key is, I have to have this same term as my result, so I'm actually going to factor out a negative 9. And so I'm left with x minus 2. And as long as these two are the same, then I can move it to right there. If I throw in some more variables, it's not going to change anything. So we'll start with the first two terms. What is the GCF between Rm and 5r? Well, they both have an r in common, leaving m plus 5. And then we have mt and 5t, which looks like a positive t, and that'll leave an m plus 5. So we have, in effect, r plus t times m plus 5. One more, and we should have a good handle on it. 2xy plus 7y minus 16x minus 56. So what is the GCF between 2xy and 7y? Well, 2 and 7 are both prime, so they don't have a common factor, but they both have a y in them, leaving 2x plus 7. And then what is the prime factor of between 16 and 56? We can prime factor both numbers and look for it, but I think what we're going to see is that it's 8. But I'm going to take out a negative 8, and that's going to leave me 2x plus 7. These two match up, home free. Y minus 8, 2x plus 7. And here's another cool thing about this. You can always check your work by foiling. Meaning, look at my answer here. If I took this answer and I foiled it, I would have, okay, the first is y times 2x, so 2xy, outside terms, inside terms, and last terms, look at there, you can check and see that you've done it correctly, and that's a really good feature. All right, next thing we're going to actually start the factoring trinomials.